All right. Okay, your questions, please. No questions? No, I'm just asking. Yeah. Guys, it's your time. Any question you have? Yes. Bucket array, you mean just conceptually, right? Yeah. Okay, no problem. The question was, can I go over again about the bucket array? No problem. To do that, what I will do is, let me copy again that particular template. Okay, just give me one moment. I'll just look for that. Kind of similar to what we went over on Friday, right? Similar. Okay. Just bear with me. Okay, I find it. Okay, so now let me go back to the notes. Okay, this guy here. Okay, so the question is about what's really the idea about bucket array and hashing. Okay. Again, okay, let me give you a little bit of context over here. Okay. It's really about how you can implement a map. Okay, how do we implement a map? And if you want to think about a map over here, conceptually, it's simply like a two-column table. So you can think about conceptually, it's more like you have two columns over here. The first column are the keys, and the second one are the values. Okay, you may have K1, K2, K3, and each one of them will just simply map to some value. It could be value 1, value 2, and more specifically, okay, all the keys must be unique. Okay, you cannot have any duplicates on your keys. That's really important. Which means given a particular key, if that exists, you should be able to uniquely identify a single row in your map. Okay, for example, if I say I got a map, and then I would say I want to query what's the corresponding value for K1. In this case, it should tell me it's only V1. Okay, and now similarly, if I say map on K3, it's going to tell me it's also V1. That's okay. So the idea would be over here, the values, you may have duplicates. That's okay. But the most important thing is you cannot have any duplicate for the keys. Okay? So now, that's how a map works conceptually. But how do we actually implement a map? We got at least two different approaches. Okay? One is more efficient than the other. Okay, let's talk about it very quickly. Okay? Let me move this guy a little bit further. Okay, let's talk about the two implementation strategy. Okay, let's now talk about strategy number one. Okay? This one is less efficient, but very straightforward to implement. This basically corresponds to the programming pattern that we have talked about so far. You basically have an array of objects, basically, right? So now we got two arrays in this case. We got one array called the keys, and then we got another array called the values. Okay, let's say this guy here, right? So the array, as long as they are of this equal size, we're okay. Okay, let's say for this map specifically, we got K1, K2, and K3. So we got K1 over here, K2 over here, and K3 over here. Of course, there might be more entries. And then for values, we're going to put the values in the corresponding position. For K1, it maps to V1. So K1 maps to V1. K2 maps to V2. And also K3 maps to V1. Okay, etc. Okay, that's strategy number one. But why is that inefficient? Okay, think about, you always want to think about when you actually want to have a realistic application, things should scale. Think about the scale of your application. Let's say the size of the array or the map, 1 million, for example. So that means the last index over here will just be 1 million minus 1, right? Starting from 0. So now, given any arbitrary key, if I want to search, if I simply say I want to search for K5, for example, okay? What would be the worst case for me to identify where K5 is? Well, if K5 is right at the end, for example, right? So that means when I run a loop, the first iteration I cannot find K5. Second iteration it cannot find either. So you got to keep going until you go to the last one. So now that means we have already gone through 1 million iterations to find out K5. Or if I say I want to search for some junk, okay, the junk key doesn't even exist. In that case, even after looking at the last index into the array, I cannot find it. I still wasted all my resources going through 1 million iterations. Okay, so strategy number 1 might work in a smaller scale, toy examples, but it may not scale much when the input size gets very large. And today in the lecture, we're going to introduce the idea about asymptotic upper bound. That's something we'll go over for the rest of the course. Okay, just a little preview. That's strategy number 1. And strategy number 2 goes like this, and I'll switch to the notes. Strategy number 2 is, oh, by the way, just one thing to mention. We also see that this week. If you think about in this way, let's say the keys over here, let's say the size is simply just n. Okay, n can be 1, can be 0, can be 1 million, it can be 1 billion, can be as large as you want. So now, when we talk about the search operation, we say that it's big O of n, which maximum you can get up to the size. The number of iterations you got to go through can go, in the worst case, corresponding to the size of the array. Okay, but that's something we'll talk about this week. You don't have to worry about this particular part for your written test. Okay. So now, for strategy number 2, we'll try to make things much more efficient. So here's the idea. Okay, I'll switch to the notes over here. The idea about hashing is very general. You can see over here, when we talk about the keys over here, K1, K2, and K3, you can see K1, K2, and K3 over here, they might simply just be some objects. They don't necessarily have to be an integer. They don't have to be. They can be person, they can be account, they can be any objects, basically. Any descendant class of the object class will be okay. Okay? So now, how does hashing work? How that's going to work is, given any k of the key, okay? So this can be any objects, any type of objects. So now, before we know about where to store k, in the less efficient strategy, we simply store K1, K2 followed by K1, K3 followed by K2, right? We always follow this chronological order. But now, in the case of hashing, we got a way to find out where exactly you want to store the keys. The way to find it out is by defining a so-called hash code function. Okay, so that's hash code. So you can think about the hash code determines where to store the keys, where to store the key. Okay, the hash code is basically just going to be a function, and then I want you to look at this particular part over here, right? Let me just wipe this out so it's a bit clearer for you. Okay, 2 things to pay attention to. You can see over here we got HCK and also A at indexing HCK. Okay, that's really the key about understanding hashing. So what you really want to think about is like this way. I'll write it down. Okay, when we say HC of K, so this tells you some index into some array. Okay, and then array, the bucket array of this particular index, which will be HCK. So this tells you the value that's being stored for that particular value, or for that particular entry. Okay, so now you can see over here, this part over here is simply used as index. Okay, so far so good. Let's go over some example to really get an idea. Something we did on Friday, but I'll move a little bit more quickly. Let's say we simply got some hash code over here. So in this course, excuse me, in this course, you don't have to worry about designing the hash code function yourself. It will always be given to you. Okay, but in 2011, you may have to learn a little bit more strategy on that. But for this course, it's okay. Let's say whatever key you're given, let's say it's an integer key for simplicity. You're going to say k rather than, so k itself is not going to be used. Not going to be used directly as index. directly as index. Rather, k modulo 11, this hash-coded value will be used as an index. Okay, this hash code will be used. Is used as index. So you can see that's kind of indirection. So this process over here is really important to understand conceptually. So you're trying to do the hashing process to have the index to store into the bucket array. So why is that called a bucket array? It's called a bucket array simply because there might be a situation where multiple keys that are different. For example, you got 25, you got 3, and also you got 14. You can see these keys are simply distinct. They are not the same keys. However, according to the hash function, okay, first of all, let me write it down to say, so these are distinct keys. Distinct keys. Well, what about their hash value? If you want to calculate the hash value, you're going to say 25 modulo 11, you will agree it's 3, right? And 3 modulo 11 will also be 3. And also 14 modulo 11 will also be 3. You can see distinct keys actually map to the same hash code. So this is so-called collision. So I believe one of your practice test question was about the definition for collision, right? Okay. Okay, so of course, in practice, you would like to avoid collision as much as you can, okay? But that's not the concern for this course, okay? Let me go a little bit more. So that's why you can see over here for this particular bucket, you can see the index is simply just 3, simply because the corresponding hash code is 3. And then we store 25 and C. So, let me make it a little bit bigger for you. You can see over here, 25 and C is stored exactly over here, 25 and C. And also 3 and F is storing as a second entry. So you can make multiple entries in the bucket. If you're lucky, you don't have so much collision, you might just have a single bucket with a single entry. Okay? And then also, this is just the third one, 14 and Z. That's stored as the third one. Okay, final thing to say before I take your questions. Why is this particular process much more efficient? Think about what it takes to actually do things to search. So when you think about if I want to search a particular K, okay, what would be the process of doing that? First of all, can I simply just go to, let's assume K is simply integer, okay? Can I simply go to A at position K? I cannot, right? Because K might be very large. For example, K might just be, for example, 25, whereas you don't have 25 in the bucket array, okay? What you should do instead is to, first of all, calculate HC of K, first of all, okay? That calculation using modulo is very efficient. It's just a low-level computation. That one there is simply a so-called constant time, which we'll also talk about today, big O of 1. Okay? It's constant time operation, very cheap. And then once we got it, we'll simply just go to indexing into the array. So A, the bucket array, at index HC of K. And whenever you want to get index into a particular array, let's say index 3, that's also very cheap. You just basically calculate a memory address and then go there directly. Okay, it's also very cheap. And that one there is also constant operation. So now you got 2 constant operation together. Overall, it is still constant for search, as opposed to linear in the previous strategy. Okay, so maybe after the 2 lectures this week, you may just want to review these 2 particular slides to get a complete picture. So while we are moving from the 2-array solution to the hash table solution, it's just much more efficient. Okay. Okay, does that answer your question, I hope? Okay, no problem. Yeah, I'll say as far as this course is concerned, understand why we're using hashing, and then understand that we are not using the hash, we are not using the key directly for indexing into the bucket array. We're actually using the hash code. And also understand what collision is, and then understand that if you go to a particular bucket over here, let's say this. If you go to this particular bucket, you can see you got multiple entries in the bucket. How can you look for a particular entry? In this case, you have to look for, you got to compare individual keys, 25, 3, and 14, right? and to look for the entry you're looking for. Okay. Questions?
So the bucket array, is it an attribute of a class?
The bucket array, good question. So as far as this course is concerned, you don't really declare the bucket array yourself. You can think about when you try to use the hash table library class from Java API, under the hood, they do have a bucket array, something like that conceptually. But you don't have to declare the bucket array yourself. So it's just there to help you understand what the hash code is supposed to do.
Okay, and when we do when we do something like in an array list, we go like array.add.
Yep.
It always adds the
To the end.
to the end,
Mhm.
right? But then how would the hash code always give? Because you say right there the hash code determines the location where
Mhm.
you got it.
Yeah, let me, okay, I see what you mean. Let me just give you another slide over here. First of all, when you talk about array list, okay, let's say certain type over here, let's say integer, right? Every time if you say list dot add something over here, whatever list you have over here, you're simply just going to add another entry at the end. It's like a pending. Okay, good. What about hash table? Okay, let's say you declare hash table over here. Let's say the key is simply integer. Just make it straightforward. To string. And then I'll say table. Let's say if I simply say new hash table, okay, I can simply leave this empty because compiler can figure out what the type is. And then you can simply leave it as empty over here, okay, but under the hood, they're going to initialize some bucket array of certain size. How exactly the size should look like is not your concern. Okay, let's imagine that. Let's say somehow under the hood they got BA, bucket array, okay? It's simply of this particular size over here. Let's say 0, 1, 2, all the way to n. Okay, what n is not your concern. It's simply set up by the compiler or by the runtime. It might even depend on operating system you're using, so that's not something you should worry about. So now let's talk about this. If I simply say table dot add, I have, let's say, k and also v, any arbitrary k. Okay. In the case of the array list, we say you simply append to the end. In the case of hash table, no. Okay. What you will do is, now let's review it again. When you say add k and v, what they will do is, first of all, they will try to call k dot hashcode, which either has been overridden by you as a programmer, or you simply use default version from the object class, which will be just based on the address of the objects. Either way, okay. K.hashcode is now going to be used as an index, okay, somewhere in the array, somewhere. Let's say here. Let's say this index is simply k.hashcode. Okay, that's the index. And then we're going to store whatever v we are passing over here into here. If there's a collision, then we have to use a bucket, right? But how you actually implement the bucket, you don't have to worry. It's not required for this course. Okay, let's just draw that conceptually. You can think that over here, for this particular index, k.hashcode is now going to point to a bucket over here. Right? And then we're going to store k and v inside. K and v inside. Right? If you just try to say another one, let's say table.add. Let me say k2, and then v2 over here. So now let's say it happens to be, let's say k2.hashcode. Let's assume if it just turned out to be just equal to k.hashcode, even though they are different keys. In that case, we have to still go to this particular position here and add it to the bucket. Okay? And then we can say maybe k2 and then v2 over here, just multiple buckets. That means you got collision. Okay. Does somehow clarify? Okay, good. Okay, for those of you who are really interested in implementing hash table, you might do this in 2011. How do you do this particular bucket array? Should it be simply an array or array of something? A 2D array might work, yes. But 2D array wouldn't give you so much flexibility because you got to be of certain dimension size, right? It's hard to grow dynamically. How about this? Okay, this is optional. How do you implement a bucket array? One option would be you can either say array list and then of array list. It's basically array of array. Okay. And each one of them is simply just going to be, let's say, entry, assuming that entry has key and value. Okay. But this part is a bit more complicated than what's required by the course, so you don't have to worry. Okay. I'm just suggesting that. For those of you who are curious about trying, that's what you can try for bucket array. Okay, again, this part here is optional. Okay, don't worry about that in the written test. Okay, guys, more questions? Yes. Okay, so basically just talk about ClassCastException, right? Okay. Let me put a bit more conceptually, okay? Like this. Let's say we got an inheritance hierarchy over here. Let's say this somehow is the root, okay? And then somehow we have something over here. We got something over here. Okay. Okay, that should be good enough. Let me just put in the class name quickly. Okay, let's say we got this many classes, okay? And then let's have the following decoration, okay? And then we'll try it, okay? Of course, you can also try it out in the Eclipse, as I suggested last Friday, okay? That one I'll leave to you, but let's explain it on the paper. Let's say the following. If I declare, let's say F, okay, static type, obj is new, dynamically, let's say, G. Okay, let's say we fix that line. Okay, as soon as you see this, what you should do is now identify where they are, the static type and dynamic type quickly. Okay, I'll use green for static type. So now static type will just be F, and then dynamic type would be G. Okay, so now let me just write it down quickly, and then we'll discuss. Static type of obj. Dynamic type of obj. Okay, let's try different casts and see what happens. Let's try. I'm going to use anonymous cast just to make the discussion straightforward, right to the point. Okay, let me put it here. Let me try a few things, and then you tell me which one, number one, would it compile? Number two, are we going to write into ClassCastException? Okay, 2 questions for you. Let me try a few. Number one, okay, let's start with these. Treat each one of them independently in isolation. Okay. Okay. Is number one okay? Okay, 2 questions here. Okay, let me put the 2 questions down. Question number one, does the cast compile? Okay, and then question number 2, if it compiles, do we have ClassCastException at the runtime? Let me be a little bit lazy. ClassCastException. Okay, but please write it down verbatim in the test. Okay, don't be like me. Okay, ClassCastException. So 2 questions here. Okay, let's try for the first one. Does it compile? Why does it compile? What's the reason? Outward casting. Very good. You guys are getting much better. Very good. Okay, compiles. I would say check compiles because upward casting, right? Or just upward. We're casting basically from F to D. Do we have ClassCastException? Why would we not have ClassCastException? I will leave that to you. Tell us. How do we decide? First of all, once you know the principle, it'll be much easier. So when will we get a ClassCastException? So let me just open a new page. Let me just write it here. I'll write it here. When do we get a ClassCastException given some OBJ cast into a particular class called C, let's say, right? So this is a very general shape, right, of cast. When do we get it? Let's forget about the example I put here. Let's forget about it for a moment, okay? Focus on this particular question. When should we get a ClassCastException? That's very good. So when the object's dynamic type is not a descending class of C. That's good, but why? What's the rationale behind? What's the intuition? If it is not a descending class, let's say if OBJ's dynamic type is not a descending class of C, what will be the consequence? Yes, exactly. That's very good. Well, may not be more, but maybe they're expecting something you cannot offer. Yeah, because it might be casting to your cousin or your other uncle, right? But pretty good. Let me write it down and then I'll explain to you. Okay, so now 2 ways to think about it. Number 1, when dynamic type of OBJ is not descendants, I'll say that's descendants of C. Number 1, okay? Number 2, you can think about alternatively, when dynamic type of OBJ cannot fulfill expectation on C. Expectation on C. Sorry about the writing here, but you can pretty much follow me. Okay, so now let's see this. Oh, one more thing I want to say. If you review your notes, let's say if I got OBJ over here, and then I cast that into C. Think about what's the intention of doing this. The intention of doing this is, let's say if the cast was okay, let's say, okay? If the cast was okay, that means this particular cast exception, cast expression, not exception, expression. This particular cast expression has static type C. Okay, we cast that into C. So that means what can we put after the dot over here? What can we put? Of course, let's say we got a parenthesis over here. What can we put after dot?
All of the bits that are the C inherits from ancestors or new attributes that the C declares itself.
Exactly. Okay, I'll put it here. So you can think about this is basically the expectation on C, which basically all attributes and methods declared in ancestors of C, including C itself, of course, right? Okay, remember that's a complete story we're telling. Okay, good. So now let's go back here, right? So now we know pretty well the precise circumstance under which we're going to get ClassCastException. So now for one over here, we will be okay. We'll be okay, right? Because now dynamic type over here is simply, let me just try to highlight it. Dynamic type for object is G. Can G satisfy what's expected on D? Indeed. Okay, so that's fine. So now, what about number 2? Does it compile? Upward or downward? Downward, right? Okay, we're casting into G, right? From F to G, basically. So it's okay because it's downward. But now, are we going to get ClassCastException for number 2? The question will be, can dynamic type G satisfy expectation on G? Yes. Good. Okay, what about number 3? Does it compile? Downward casting, okay? Compiles because it's downward. I'll just say down. Do we have ClassCastException? We do, because now dynamic type is simply G. Can it satisfy expectation on H? No, not in general. Okay? Okay. ClassCastException occur. Okay, and then you can see the other two, B and A. That's why I said, when you said the expectation might be more, it's not exactly accurate. Because if you talk about expectation on B and A, and you compare them with G, they're not exactly like a subset or superset. So it might be that this might be the expectation on B, for example, and this might just be the expectation on G. So they just overlap somehow. But there might be something that's in here that's not in here, and vice versa. Okay, yeah, just want to mention that. But if you're not still very comfortable, you want to make sure you're convinced, feel free to try this in Eclipse, right? We did show you how to do that on Friday, okay? Maybe not just for the written test. I think it's useful for you to understand anyway, in general. You first, yeah.
What is the actual benefit of upward casting?
You can think about, it's more like about access control, okay? Just in general. Let's say, for example, I'll just make up some example here. What's the benefits of upward casting? One potential benefit would be for access control. I'll write it down. Upward casting. So it would be somehow access control. Let's say we got class A over here, and also we got class B over here. Let's say for class A, we simply got, let's say, username. And over here for class B, we got password. Okay, let's say that. Okay, and then when we say A, and then, oh, let's say this. If I simply got B, objects is assigned to new B. In this case, I can definitely say obj.username. I can also say obj.password, right? So these are all okay. But let's say this. Somehow, when I want to pass a value to some other user, I may not want to make my passport available to them. In that case, what I can do is I can pass them just an 8 objects statically. In that case, I can do some upward casting. For example, let's say this. Let's say retrieve. You might simply declare something like return A. Retrieve objects over here. Let's assume that you simply got, okay, let's assume we got this in the context already, okay? Let's assume in the same class. What you can do now is you can say cast obj to A. You can think about any potential caller would only retrieve objects of static type A. Okay? So now let's say the following. If I simply try to call retrieve objects, and remember this is return value, right? Static type. Retrieve objects, okay, it's a call. Now, can I say username? Yeah, right? Because A does define username. Okay, that's not a problem. But now, can I say retrieve object password? No, right, not really, right? Because now retrieve object statically is A, but now, of course, it does not support password. But notice that under the hood, you can think about retrieve objects really pointing to a B objects because dynamically it's B, but we are actually protecting it from being accessed as a password. Just one way to think of it. But that's one is a little more advanced. Okay. You can think about in this course, we show you what's the consequence of doing upward casting or downward casting, but when to do which one is more about your design decision. Okay. Yeah.
So ClassCastException, that's the only case that happens.
Yes, when you try to cast into something that's not the ancestor class of your dynamic type, that will be the only case. Yes, that's correct. Yes. But of course, you want to understand what's the rationale behind, right? Because if you memorize it, you can easily forget very soon, right? Good. Hey guys, any more questions? Okay, call by value, yes. I can do that. Yeah, bear with me, I'll find it out. So I don't need to build things from scratch. Okay, I think I found it. Good. Let me see. Okay, I think this will be good. Okay, call by value versus call by, reference type versus primitive type. Okay, call by value. Let me talk about a simple case that's in the slides. You can also refer to the more complicated case in the notes. Okay, the same idea. Let's say we have a class called circle. And then we got an integer radius over here, and then we got set radius, and then this radius is r. Okay, so now you can see that a parameter type over here. So this is a primitive parameter. On the other hand, if you see the other example over here, you can see when we say set radius over here, you can see it's a reference type, right? Okay, so now this one is reference parameter. Okay, we're going to see how the two versions might work a little bit differently. Okay, that's something you want to pay attention to. Let's see the primitive value. The idea for both cases is the same. Okay, every time when you are trying to call, let's say for example here. First of all, I created a circle objects. Okay, so over here, I simply say circle. Every circle has a radius. Okay, and then simply say new circle. Okay, so C is now pointing to the new circle. Let's say initially simply just 0. Okay, and then I have this particular integer arguments. I'll simply put it here. Okay. It's a primitive type, so the way I visualize it is like a box, like a placeholder. So there's arguments over here, and then 10. Okay, so now we're considering this particular method call. Okay, and the context object, of course, is C. And we're passing arg, which is over here. Okay, so now what exactly is going to happen is there will be an implicit assignment that will be done. You don't have to do it, but it will be done for you. Okay, so now we're already there. So when I call this particular method here with arguments, what they will do over here is they will first of all go to the definition for this method here when we call that, right? And then what they would say is r, the parameter value is simply assigned to arg. That's what they will do. Well, in this case, when you do assignments on primitive value, what does that mean? You're copying the value, right? So you can think about we got another box over here, which is called r, okay, the parameter. is simply going to copy over the value for 10. Okay? So now everything else will just work smoothly. So now when I say this dot radius is assigned to r, r is now 10. So I'm going to set it to 10. Okay, like that. Are we okay with this? Okay, let me do one more thing and ask you about it. What if I try over here, let me add a second line over here. If I say r is assigned to 20, okay, just for the illustration purpose, am I also going to modify the argument value over here to be 20? No, right? You can, once you visualize, you can see. What I'm going to update is just this particular copy to be 20. The original one that's being passed over has been copied already. That's why it's called call by value. The value has been copied over. So now this remains to be 10. Okay? Good. So that's why when you see the slide example, you will see some JUnit tests over there to ensure. Okay, that's about primitive value. In the case of the reference type, it's very similar, but still let's visualize. Again, I have this line here. C is now pointing to circle over here. Let me write it down very quickly. Circle, and then we have radius. Okay, initially just 0. And then we're going to do another circle. Okay, another one. Let's call that arc. So that means we're going to have arc. Let me have a different color. Let's say arc over here. Arc is also pointing to another circle over here, and then that's also circle, just different objects. And then we're going to initialize the radius to be 10, right? So now in this case, it's going to be radius and then 10. We got two circle objects, okay? One is being pointed to by C, the other one is being pointed to by arc, okay? And then we'll call this particular method here C.radius arc. Okay, that's what we'll do. Let's see what's going to happen, and then we'll do a little bit modification. So we'll call this particular method setRadius C, and the same principle applies. There will be an implicit assignment that will be done for you. You don't have to do it, it will be done, which is over here, you will say C, the parameter is simply assigned to arc. So now, what will be the consequence of doing this? Previously, when we said r is assigned to arc, we are basically just copying 10 into 10 over here because it's primitive value. But now, it's not primitive value anymore. What are we copying really? Oh, well, the argument, are we copying the whole circle? Or we're copying something else? What are we copying really? The address. Okay? So you can see, as we keep emphasizing, when you have reference type, for example, arc over here, the arc is simply store the address of some circle objects. Okay, that's really important. So now when you say C is assigned to arc, you're basically copying over the address that's stored in arc into C. That's what you're doing. So now how do we draw the diagram? What you will draw is over here. You know what? I think to avoid confusion a little bit, if you allow me, the C over here and the C over here, don't get confused. They are different C. They're in different namespaces, right? To avoid confusion, I'm going to rename them very quickly. Okay? Can we just say this is D, okay, and this is D, okay? And now, and then over here we'll simply say D is assigned to arc. So what will be the consequence of that? Is it going to do D is assigned to another new circle? No, right? You only copy the addresses. So what's going to happen is like this, okay? I'm glad you disagree. What's going to happen is this. You're going to have D over here, and D is now going to point to wherever arc is pointing to. Okay? So now we're going to say this radius, this is basically the C. That's the objects we're talking about, the context objects. And then the radius will be D.radius. In that case, D.radius will be 10. Copy that over, you got 10. So now, some question to follow up. Let's say after this guy here, there are two kinds of changes I can make. Okay, number one, I can try to say D is simply reassigned to another new circle objects. Let's say 100. If I execute this line over here, number one, is it going to change arc so that it becomes 100? Is it? You will say yes. In fact, it will be no. Okay? Because thinking this way. Okay? Because now when you say D is basically currently it is pointing to this particular circle object, right? When you say it is now assigned to new circle, you're only reassigning D over here. You're not really affecting this particular circle object that's being pointing to. Okay? So what's going to happen is D is now going to point to another new circle whose radius is 100. And that's what's happening here. So you cannot reassign. When you reassign the parameter over here, either there's a primitive type or it's a reference type. It's not going to affect the arc over here. On the other hand, the kind of change you can do when you got reference type parameter is by using aliasing. Okay? So now if I just do this one here again, I think for this one I'll make it carefully. Okay? Okay, let me just do another page for you. Okay, the same one. Okay. Let me just draw very quickly. Okay. Again, over here we got D, and we got D over here. So now the second line I would like to do is to say D dot set radius. And then let's say 100. Okay, and then after this guy over here, if I say assert true, right, JUnit test, arc, which is a circle, dot radius equals 10. Am I going to fail or pass? I heard pass. Anyone who would think we would fail? You would fail? Why would we fail? Yep, so we do have ADC issue, right? Okay, let's visualize that. That's correct, we're going to fail, but let's see exactly how we're going to fail. Okay, again, let's see this. First of all, we have this C over here. C is going to be a circle, so C is pointing to this particular circle over here. Initially, it would just be 0. Radius is simply 0. And then we have arc. It's also pointing to a new circle over here, and circle. Radius is 10. Okay? And then when we say C dot set radius arc, right? What that would do is, first of all, we're going to do call by value, which means implicitly we're going to say D is assigned to arc. Right? What we said. So now that means D is now pointing to the same argument circle over here. Okay? And then after executing this line, we simply set this. This, by the way, is simply just C, right? Okay? It's a context object. So C dot radius will just be copy over R dot radius, which is 10. Okay? That's what we have done just so far. Okay, up to here. That's what we have done. So now we are worrying about this particular line. D dot set radius. Is it going to affect the same circle that's being pointed to by arc? Well, if you look at the diagram, yes, it is going to. Because now, if you look at that, D over here is pointing to just the same circle over here. So when you say set radius, so now it is going to set it to be 100. So now, when you try to execute this particular assertion over here, arc the radius equals 10, would that be true? No, it's not true, because it's being set to a 100. Okay, so this one over here is going to fail. Okay, yeah, when you actually look at the slides, that's exactly the kind of JUnit test I was trying to set up for you. Okay, but callback value is really important actually. When we talk about the polymorphic feature arguments in the inheritance lecture, we did mention a little bit about callback value, if you recall, right? They are all connected together. If you don't know what I'm talking about, that's okay. Maybe that's not okay. Yeah. Does that answer your questions? Okay, good. Yes. Yes. Oh, you want me to a particular question? Okay, let me bring it up. Okay. Okay, you were talking about the written test questions. Let me bring it up. Okay, lectures. 2031. Okay, so then I will go to that particular one. Okay, and then I will go to, and we go to solution directly. Which one? 4A. Okay. What about it? Yes, go ahead. Ah, okay, I see what you mean. It's more like a special case, okay? You know, you always got special cases to deal with, unfortunately, right? I'll say in principle, yes. When you're talking about compilation, you should only focus on static types, but only in this particular exceptional cases, you want to consider also dynamic type, okay? Okay, let me just switch to iPad, and I know what you want to ask, okay? Okay, over here, let's talk about two cases, okay? I'll make it very brief. A here and B here. Okay, let's first talk about the static type case, and then we talk about the special cases, okay? Case number one. Object A is new A. And then we got B. You know what? Let's say I don't even put anything here. I'll just say ... means something, okay? Something to be done, okay? And then object B is also something to be done, okay? Now, if I say OA is assigned to OB versus OB is assigned to OA, I hope at this point you can tell me which one is invalid. The second one, right? Good, okay? But how do we tell, right? So now, first of all, this is not going to compile, okay? Not compile. Okay, how do you judge? First of all, we know that the static type for OA is simply just A. And the static type for OB is B. Can A fulfill what's expected on B? No. Okay, so it doesn't compile. Okay, so that's the case where you can see over here, the left-hand side and right-hand side, they are simply just variables. There's no new keyword. In that case, you only look at the static type. Okay, what's special is when you try to do things like this, when you're trying to initialize your object or reassign your variable, you're going to use a new keyword. That's the case, you have to consider a little bit about dynamic type. That's the only occasion. Okay? So now, if you think about it this way, I'm going to write a second example here. So now, 2, okay? If I say A, they're completely independent example, okay? They are not related. New B, B, new A. So now we want to judge to see the two green lines over here, which one is valid and which one is invalid, right? Similar idea over here. Basically, you're saying this. You can think about this is like new objects, which can fulfill expectation on B, right? Because B can fulfill anything that's up to itself, okay, down to itself. So now, would this be enough for static type A? It would be, because we know that everything that's expected on A can definitely be fulfilled by B, but not vice versa. So that's why this will be okay. Okay, that's the only occasion you have to compare both together. That's the only occasion. But when you only have two variables, like say OA and OB here, you only consider static types. Okay, okay. Make sense to you? Okay, good. But you know, to be a real scientist, you always have to know what are the normal cases, in principle, what are the exceptional or like special cases, right? Yeah. Yes.
For the example where you do like
One or two?
let's say number one.
Okay.
It does work, right?
Uh-huh.
OA equals OB. But let's say you had like a third class that's
Sure.
a descendant of A and B.
Okay.
And you did A equals to C.
Yeah, let me build it up. Okay.
Yeah. But then
Yeah, one moment. Yeah, let me build from scratch so everybody can see the example, right? So what are you suggesting? You're suggesting A here?
yeah, same thing, but then you're just adding C to the bottom.
You mean B extends from C, C extends from? No worries. Okay, and then?
And then let's say you created a new object, A object.
A, okay.
And it's dynamic type, let's say it's like B.
Okay,
And then you had your B object,
okay.
and its dynamic type is, let's say, also B.
Also B, no problem.
Then, sorry, I got in my head.
That's okay, take your time. Oh, you're basically asking, I guess maybe what you want to ask, I guess. Can I do OB is assigned to OA? Given that OA at the moment is pointing to a B objects. OB is also pointing to a B objects. It seems to us as a programmer, we are flexible, right? We can be as flexible as we need to be, right? So now, can I simply say OB rather than pointing to here? It's now just going to point to here. It seems to be a very valid reassignment of the reference, but can we do it? You assume no, but why, right?
It's a static type.
Exactly, okay? Again, okay, you're right. First of all, this is not valid, okay? Let me mention that, okay? So this is not allowed, okay? Let me write it down, and then I will tell you a story, okay? Not allowed. Okay, again, this is not valid simply because the static type of OA over here, which is A, is not descendants of static type of OB, which is B, right? Because A cannot fulfill what B. Even though OA is really pointing to a B object, it doesn't matter, right? Remember what we said briefly in the class? Remember the A+ challenge I gave to everybody, right? Basically, it's an undecidable problem, meaning that compiler in general just cannot keep track of the dynamic type for any variable at the compile time. It's just not possible. So in this case, if you're really sure OA is really pointing to a B object, what I can do is, what should we do? Cast, exactly. That's the whole story, right? Of course, if you try, okay, this one is not valid, but if you say OB is assigned to, if you're so sure, cast into OA. That's okay. Okay? And so this will be fine. Let me go a little bit further, even though that's not what you're asking, but I thought people might be interested in knowing anyway. Let's consider another assignment. Can I say OB is assigned to COA? Does it compile? It does compile because it's a downward cast, right? downward cast. Because OA statically is A, and cast into C is a downward cast. Very obvious, right? But given that it compiles, that means we can execute the code. What's going to happen? ClassCastException, right? ClassCastException because dynamic type of OA is not descendants of C because it cannot fulfill its expectation, right? Okay. Again, if you want to see it over here, dynamic type is simply just OA is B. Okay. Dynamic type is simply here, but you're trying to cast into C, it's not going to work. So now that's why instance of also comes into play, right? What you want to do is whenever you will try to do such a line, it can be improved by saying if OA instance of, okay, is a keyword, C. If that's true, at the runtime, you're going to do the cast. So at the runtime, when you actually do this check, you're basically asking, can the dynamic type of OA fulfill expectation on C? Can it? No, it cannot, because dynamic type is simply B over here, so it's not going to fulfill. But rather than giving you a ClassCastException, instance of check will give you either true or false. So it will just give you false. So that means you will bypass this guy here. You will just go all the way to the end. So you can prevent from ClassCastException. So that's why instance of is a nice safety net. How about that? Right. As you can see, it is basically the complete story we're trying to tell about inheritance. Yeah. Okay, anything else? Yeah, it's nice. Today we cover call by value. We cover a little bit more hashing, and also cast, instance of, and ClassCastException. That's nice. I think those are important topics. Yes, first. Yeah.
What you were trying to ask originally was that if you have an EC object with, let's say, C,
Let's see. Yeah, let me write it down. Okay, you say C, OC is new C. Okay, and then what would you like to do? Let's try. If you say OA is assigned to OC, well, in this case, of course, you can. Because as far as the assignment is concerned, OC has a static type C. OA has a static type A. And C can definitely satisfy A's expectation. It's a descending class. So that one's fine. I think that maybe what he was trying to ask was, even though in this particular case, this one is not really valid, but we know that pretty well. Dynamic type of OA can really support what's expected on OB, right? So in that case, the compiler is not flexible enough. You have to do either cast or you just got to bear with the compilation error. So doing cast is actually very common if you look at object-oriented code. But be very careful because sometimes your guess might be wrong when the things are getting very complicated, right? You want to do some instance of check. Okay. Yes?
We should look at determining if there's going to be exception or not.
Yes, correct. Because remember, ClassCastException only occur at the runtime. Whenever you want to determine if a phenomenon is going to occur at the runtime, you got to look at the dynamic type. Yes. Yeah, again, the principle will be, if you only talk about compilation, I would say only look at the static type, except for that special case we talk about, right? But if you talk about runtime behavior, whether there will be a ClassCastException, or whether the instance of will give you true or false, or whether which version of the method will be called. For example, get tuition from resident students versus non-resident student version. They all depend on dynamic type. Yeah, as I said, try your best to really get things clarified. You can still ask me during the review session. I think that this inheritance idea doesn't really just last just for this course. It's not true. You're going to need that, for many other courses beyond this one. Okay. Yes. Yeah. Array list and hash table, yes. I tell you what you should know for collection, okay? That part is not difficult. I'll just mention the slides to you about the collection. You may be given a fragment of code to trace and see what the output is. That was easy, okay? What I want you to really also study for is this. Let me get there and then tell you which slide you should really look at. Over here. Okay, so this guy here basically just tells you, for example, if you got array list of E, right? So E over here might be instantiated by either string or any class, like a point. So now, when you say list 1, okay, let's, I'll give you one example, okay? Let me, again, find it out. Okay, bear with me, I'm gonna find it out from the iPad. Give me 30 seconds. Okay, I found it, so I'm going to copy that and then I'll show it to you. Okay. Yeah, so when you study, make sure you study, for example, slide number 8 and also slide number 12 as well. Okay, just make sure you go over that. I'll go over one of them with you. Let's say this guy here. You can imagine that the way they actually implement array list in the Java library is by declaring class over here and you say array list. And then you got angle brackets over here and then you say some parameter E. Okay? You don't have to worry about how to define this class yourself. We don't have time to cover that for this course. But either you're going to learn a little bit about it in 2011, or maybe when you get to software design 3311, you'll learn about how to declare generic classes. But for now, let's focus on what we know. The E over here, you can think about is to declare a type parameter to be used in array list class. What I meant by that was, once you declare E to be over here, you can use it over here, and over here. So what do I really mean by use it? It depends on how the caller of an array list, how do they instantiate E into? They can instantiate E into different types. Okay, let me give you an example. Let's say over here, the first case, the first example. Let's say I simply say array list string list 1, okay, versus array list point list 2. You can see these are basically two instantiation. You got string over here versus point. So what's the consequence of doing these two instantiations? Okay, let's make it precise. Okay, for the first one, in pink. Okay, for the first one, you can imagine there is a spare copy of the code for array list that's made side aside. Okay, you don't do it, just done implicitly for you, conceptually. So for list number 1, what's going to happen is string over here is going to instantiate this E, right? And every occurrence of E will be instantiated accordingly. String, string, and also string. Okay, that's one version. That's the consequence of doing this particular declaration. Okay, let's see how the second one is going to be done right away. Okay, for the second one, imagine there's another copy of the array list set aside. And then what we have is array list and then point. Okay, so now it's conceivable to imagine it's now point over here. And once this has been instantiated, every occurrence of E over here is going to use point accordingly. Okay, number one, you want to understand this very well. Okay, it's about how to use generic classes. So now let's try something over here. Okay, you will see the example in the slides as well, but I'll just do it here. Now, can I say the following? List1 dot add. Okay, and then I would say, assuming that we got point, constructor x and y, let's say 3 and 4. Can this line compile? Well, once you visualize what's happening here, it's quite obvious, right? Because now list1 was declared specifically to this particular version over here, right? So now, what should be the parameter type for add? Should be a string, okay? So you wouldn't compile, okay? Another one, okay? Let's say we also got remove over here, right? So now, if I got, let's consider independent one. If I say list number 2 dot remove, add position 2, for example. Okay, we only talk about compilation. And then I say string s. Would the orange line compile? Why would it not compile? Anybody? You're trying to explain to me? Yes. Why would it not compile? Yeah, the return type for list2.remove is going to be points, as we have seen on the right-hand side instantiation, right? Okay, good. So now you can see that for this guy here, list number 2 basically is corresponding to this particular instantiation. When you say remove, remove is going to return the points, right? Can you assign a point to a string? No, you cannot. So also it doesn't compile. Okay, just another example. So that's what I expect you to know from the collection classes. Okay, so you should really keep track of what you have instantiated the parameters to be. Of course, in the slides also I show you the case for hash table, where you got 2 parameters, but similar idea. Okay. Okay, any more questions? We can get another 10 minutes, no problem.
In the practice test question solution,
Yeah. Mm-hmm.
the answers for like the first 2 questions, like the short answer questions, or short answer, the answer's like really short. Like I know like that wouldn't get us full marks, right? If we were to write something.
Oh no. Actually, they are standard answer. Okay. I would say in the written test, you will be given 50 minutes tomorrow, 50. Okay. I would say for each question there, of course, it doesn't really mean the more you write, the more marks you will get. It's not the case, right? You want to make sure you cover all the essentials over there. For example, if I go back there, let me again open that question there. Okay, you can see somehow I boxed the keywords you should really cover, for example, right? You want to say 2 unequal keys are turned into 2 equal hash code. That's basically when I ask a TA, look for the keywords from student's answer, right? You want to make sure you cover them. And what would be my advice? I would say I typically don't really ask too many definition questions, right? So as long as you explain to show that you cover all the essentials, to say you got 2 different, even you say 2 different keys mapped to the same hash code, even that would be okay, right? The main question you will see tomorrow will be given a fragment of code, or you want to see whether things compile, or if it doesn't compile, why, right? Yeah, that's kind of the thing I would expect to see. Okay. Okay, guys, we still got, well, we said until 11:20, but you can ask me more if you wish. I can take another few questions if you wish. And by the way, there was a Moodle survey from yesterday, right? You may just want to complete as soon as you can. Just tell me when you're available so we can work out the schedule. Because I need to give a review session for 3311 as well. So I want to work out the time. Okay? We okay? All right. One moment. Yes. Oh, no. Oh, because okay, next Monday will be our last class, and then I'm thinking about maybe next Friday we can hold a first review session, depending on your availability. But our exam will be on the week of December 13th. For that week we hold more. Yeah. All right, I'll see you in the class soon.